Good evening, dear students. Welcome to your chemistry online class. As we have discussed yesterday, we'll try to cover maximum portion in this online classes so that we can cover your syllabus before time and we can revise it. And yes, we will read your reduced syllabus only. So let us start your first class. So the name of your first chapter is periodic table, periodic properties and its variation. So from the beginning, I should say you, before watching this video, you should read once the 5th chapter of your 9th class book. Then only you can understand this one more clearly. So first term, you should understand what is period. Period means what you should understand first. As I have given some examples earlier also, that you have 8 periods in a day at your school, and for different day the number of periods of the different subjects it is there. If we will talk about the 6 days of a week, again that 6 days it repeats in the next week and it continues the same way in the next weeks and in the next months, as it is coming within a certain period and certain gap. You can say certain gap, that's why it is period. Anything if it is repeating after a certain gap, then that for that we can use the term period. So here also you see in this periodic table, here is also the repetition it is going on. You can see one type of elements that are categorized in one group, but their atomic number is different. See, here it is 1. If you will see, normally after 1, 2 should be here, 3 should be here, but it is arranged according to the increased atomic number and in the row wise. Why? Because the properties of your lithium, it's similar to sodium, not it is similar to your beryllium or magnesium. So all these elements are arranged in a completely proper way so that the same characterized elements will stay in one group. They will occupy the position in one group. Simply we can say one type of elements, those who so same properties, they should categorized in one group. So as it is coming back after a certain gap, that's why it is called your period and periodic table. That means what? See, here lithium is there, lithium's characters, sodium, potassium, all these their characters, it is same. And lithium, after lithium certain gap, sodium is coming and it is pursuing the same properties as your lithium. That's why it is coming after a certain gap, it is called your period, and combining this is called your periodic table. I hope you understood why we should use the term periodic table. And some other facts you should know about the periodic table, which one you have already read before. So what is period and what is group? This vertical one is called your group, and your horizontal rows are called your period. And you know, just pause the video for some time and just answer me and answer yourself, how many periods are there and how many groups are there. I hope all of you know there are your 7 periods and 18 groups. I hope everyone is clear about this. You may get the short question about this. So 7 periods and 18 groups. Then, so your first column, that is group 1A, is called your alkali metals. Then group 2A is called your alkaline earth metals. Sorry students for the disturbance. Okay, then this side, if you see, your completely right side, that is called your inert gases or noble metals or your zero elements. Then slightly after your noble elements is called your halogens. I think all of you can see this 7A is called your halogens. Like that, different groups, they are having different names, which one we are going to discuss later on. First, you should be very clear about your metals and non-metals. So completely left side and including this one also, all this is called your metal. So you can say maximum positions or maximum places is occupied by metals in the periodic table. Then here this right side one, you know, these are the gases. Then non-metals is your 7A and some of 6A and some of your 4A and 5A also. And what are this grey color one? This grey color one, they are called your metalloids. And you know what is your metalloid? Metalloid means they show the characteristics of both metals and your non-metals. Here another easy thing to find which one is your solids and which one your gases, means which elements are your solids and which elements are your gases. You can see small squares. You can see small square, this one. So wherever your square is there, that one is your solids, and wherever like this symbol is there, this is your gases. Okay. Then let us see. You can find the other liquids and gases by seeing the notation. Here it is there, you can see and you can find. From here you can find. Then you see from 1B to your 7B. Sorry, 1B to 8B. 1B to your 8B. I think everyone can see here. 1B to your 8B. All these are your called transition elements. Okay, transition element. And your group 13 to 17. Group 13 to 17, they are called your representative element. 13 to 17 means which one? 3A, 4A, 5A, 6 and 7A. They are called your representative elements. And which one is called your representative elements? Just now I said that is 3A to 7A and also your group 1A and 2A. So we can simply say group 1A to your 7A are called your representative elements, and 1B to 8B transition elements, and your 0 group, that is your 18th group, that is called your noble gases or inert gases. So now let us see what is given in your book. First is the introduction part. So introduction part, here it is given about the elements. First it is given about the element. I think everyone is clear about what is atom, molecule, element, compound. You should revise these 4 terms. Then you see Daubigner. Daubigner only, he was the first fellow, first chemist, or you can say first scientist who started this periodic table, or about the categorization of the elements. He only started the categorization of elements and ultimately the concept of your periodic table. He has not made any table, only 9 elements he has arranged. But why he thought of categorize the elements? If you'll take one example, if normal your grocery store which is in the village, there no things it will be categorized. Wherever the shopkeeper want, that fellow will keep, and while asking, while the customers will ask, that owner will give, and he has not categorized anything. But if you will see any a big mall, in the mall if you'll go, everything it is categorized. Like clothes stores, it will be in separately, then your grocery, completely it is separated. And if anyone, any customer can go and nicely find the required things. Why this it is easier? Because whatever the things are there in that store, if it is kept separately, then it is easy to find. That's why in the mall everything it is categorized, but it is not found in the small store, small grocery store or any store. The same way, if all the elements will be not categorized, just simply in nature this much 120 elements are found, if you will hear or if you will see, then it is very difficult to remember their category, their characteristics and how they behaves. But if we categorize them according to their behavior and properties, then easily we can remember the elements and their characters. Suppose if you see, as I told you, the same showing properties elements are categorized in one group. That means what? If you will read about your lithium, then ultimately we have read about your sodium, potassium, rubidium and so on. The same way, if we have read about this beryllium, then we have read about the remaining elements also. If we will categorize them according to their behavior, then for us also it will be easy. If you will understand or if you will remember the characteristics of some elements, then ultimately we can remember other elements properties also. That's why only this categorization it started. So first it was given by your Daubigny, that is your three triads. Triad means in one triad 3 elements will be there. So this Daubigny, Newland and Mendeleev nicely you have read in your 9th class. So I am not repeating here. If I will repeat, then this video will be too long. It is there already and you have understood nicely. So you can revise this one from your 9th class book. And if you will get the question, maximum contribution for the periodic table is given by whom, then remember that is your Mendeleev. Maximum contribution for the periodic table, it is given by your Mendeleev only, because he has done almost maximum elements present at that time, and the discovering elements also he has left the space. But that one also, it was means limitation were there. After that this modern periodic table came. And you know about this Newland has arranged the elements according to their musical notes. That's why it is called Newland's law of octaves, because your musical notes, it is 8 musical notes are there from Saregama to your Padhanisa. Okay. Then we will see this Henry Moseley. Henry Moseley, who is this? This Henry Moseley has discovered the modern periodic table and the modern periodic law. You may be asked, what is Mendeleev's periodic law and what is modern periodic law? So the common difference between your Mendeleev's periodic law and modern periodic law is, Mendeleev's periodic law, it was completely based on the atomic weight. That means in the Mendeleev's periodic law, the elements are arranged in the increasing order of atomic weight. But in the modern periodic law or modern periodic table, the elements are arranged in the increasing order of atomic number. This is only the difference between your Mendeleev's periodic law and modern periodic law. Henry Moseley has discovered the modern periodic table, but the extended form of the modern periodic table or the long form of the modern periodic table is given by Niels Bohr. Remember the name? Niels Bohr. Then you see here what is periodic table. In this table it is given, in this box it is given, a tabular arrangement of elements in groups and periods highlighting the regular trend in properties of elements is called a periodic table. This regular trend means what? Their variations. Okay, variations means in different groups the characteristics will be same, but their variations it will be different in different groups. That is called your periodic table. So we are going to read about these variations of different properties. So this is your modern periodic table, the updated version 1. Okay, so let us see the individual name of the individual groups. Group 1, that is called your alkali metals, or group 1A also you can say. Group 1 alkali metals, and then group 2 alkaline earth metals, group 3 to 12 all that you call your transition elements, then group 13 boron family, group 14 carbon family, group 15 nitrogen family, group 16 oxygen family, group 17 halogens, and group 18 zero group. Let me show you in the periodic table so that you can remember easily. So first one I have shown you, this is your alkali metal, next alkaline earth metal, these are your transition elements. Next boron family, that is 3A, 4A carbon family, 5A nitrogen family, 6A oxygen family, and 7A halogens, and 8 your noble gases or your inert gases. Next let us see what is given. Yes, some other questions also, short question also you may get regarding the shortest period, long period and longest period. So let us see. Shortest period, that is your period 1. Short period, period 2 and 3. Long period 4 and 5. Longest period 6 and 7. Once again I am repeating. Shortest period period 1. Short period, period 2 and 3. Long period, period 4 and 5. Longest period 6 and 7. Let us see the number of elements present in different periods. Why it is called the shortest period? Because in period 1 only 2 elements are there. Group 2 and 3 are called short period because there were 8 elements. Long period, your 18 elements, and in longest period, that is period 6 and 7, 32 elements are there. And you have read in your lower class that how can you determine the number of elements present in the period? By 2n square rule. So let us see how. You have already read, but shortly I will say. 2n square rule, where n is the number of period. So first one, let us see, 2 into n means 1. First period, so 2 into 1, 2. Suppose we will see for period 4. 2 into 4 square, that is 2 into 16, 32. Sorry, actually by this 2n square rule we can find the number of electrons present in the period. Now the thing is, how can you find the number of elements present in the period? That is, see, if the n is even, n means the number of cell. Like if you will take the first period. First, let us see what is the formula to calculate the number of elements? If n is even, the number of elements equal to n plus 2 square divided by 2. If n is odd, then n plus 1 square divided by 2. So let us see one example, that is period 2. So period 2 means n is equal to your 2, means this is even. For even we have the formula n plus 2 square divided by 2. So n, in place of n we will put 2, 2 plus 2 square divided by 2. So 2 plus 2 4, 4 square 16, 16 by 2 equal to your 8. So 8 is the total number of your second period. The same way let us see period 6. Period 6 means your n is 6. So n plus 2 square divided by 2. Number of elements equal to, in place of n we will put 6, as we are talking about the number of elements present in 6th period. So 6 plus 2 divided by 2. So 6 plus 2 8, 8 square your 64, 64 divided by 2 your 32. That means in 6th period 32 elements are present. Now let us see one example of your odd one. If we will see the example of 5th period. So for odd we have the formula n plus 1 square divided by 2. N equal to, we have taken here for 5th period, so 5. 5 plus 1 square divided by 2. 5 plus 1 6, 6 square 36. Sorry, 5 plus 1 6, 6 square 36, 36 by 2 your 18. So you can see here in the 5th period your 18 elements are present. Now one more last example, that is your period 7. n plus 1 square divided by 2. 7 plus 1 square divided by 2. 7 plus 1 8, 8 square your 64, 64 divided by 2 equal to your 32. That means 32 elements are present in the 7th period. And to calculate now the number of electrons present in one period, that one we can calculate by your 2n square rule. So let us see one example. Let's do that is your 6th period. So 2 into, in place of n we will put 6, as we are talking about your 6th period. 2 into 6 square 36, 36 into 2 72. That means 72 electrons are present in your 6th period, I mean in 6th period elements. Okay, now let us see next one. Okay, here it is given, see the elements present in the respective groups. Like in period 1a 2 elements, that is your hydrogen and helium. Like that in period 2 the 8 elements, your lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and so on. So up to 7th period it is given. But you see after 4th period it is difficult to mention all the 18 elements and 32 elements. That's why only the first elements and the last elements name it is given. You can see here also, you can see the number of cells. In period 1 there are only 1 cell. In period 2 there are your 2 cells. In period 3 your 3 cells. So we can see the period number, it signifies the number of cells present in that period. So if you are talking about 4th period, that means there are number of cells are 4. If you see in the periodic table, I think you can clearly understand. So let us try to draw group 2. Sorry, period 2. Period 2 you can see lithium, beryllium, and it up to your neon. So lithium 1, let us draw lithium. Atomic number is 3. The electronic configuration is 2 1, that means 2 cells. In first cell there will be 2 electrons, and in the second cell there will be 1 electrons. Now let us see beryllium 1. Beryllium electronic configuration 2, 2. Here also 2 cells. Like that, if you will see the last one, that is your neon, you can see here neon electronic configuration is 2, 8. Means in the first cell 2 electron and in the second cell 8 electrons. So I think you have understood. Your period number, it signifies the number of cells present here. Your group number, it signifies the number of valence electrons present there. Like see group 1A. Group 1A means every elements of your group 1 is having valence electron only 1. Group 2A means every elements of group 2, they are having valence electron. I am talking about valence electron, that is 2, not valency. Okay. Then if I see your 0 elements, they are having the valence electron. This is the 8th group, no? That's why the valence electron will be your 8. Like that, if you will see 7th one, here the valence electron will be 7. So remember, the group number signifies the number of valence electrons present in that group or that elements, and your period number signifies the number of valence cells, or the number of cells, not valence cell, sorry, that is the number of cells. Your period number, it signifies the number of cells. One more thing I didn't say at that time, that is your lanthanides and actinides. They are from the group 6, sorry, period 6 and period 7. You can see this lanthanide series from your here, means 6th period, and actinide series is from your period 7, that is 57 to 71. In order to just adjust, because this many elements we can't adjust in within that periodic table, that's why below it is placed, that is atomic number 57 to 71 lanthanides, and your actinides 89 to 103. Here it is written, you can see lanthanides group 3 of the 6th period and actinides 3 of the 7th period have similar properties because they belong to the same group 3. They are shown at the bottom of the periodic table because they are large in number, and if shown in the main body of the table, it will distort its shape, means the shape of the periodic table it will change. That's why just to fit the periodic table down it is placed. And what I have told you about the what your group number signifies and what your period number signify, it is given in this period, in this table, small table. You can read your own, but this one already I have told just now. You can read your own this one. Now let us try to understand what is your typical elements. You see, here are some representative of the following elements. Like you see, sodium, magnesium, this set from aluminum, silicon, phosphorus, sulfur and chlorine. They are called the typical elements because, or you can say they are the representative elements because they represent the below elements. That's why they are called the typical elements. Okay students, so we have completed your first page and second page and third page of your book. Then in the next class we will start from your periodicity, cause of periodicity. Okay, so this video you watch carefully and try to understand. If you are getting any doubt, you can send me in the WhatsApp or you can ask in the doubt clearing class. After completing this lesson we'll have your doubt clearing class in the Zoom. Thank you.